We design our first beam as a basic square. We use only one plate of brass because its density is high and not quite strong. As well as the steel, we use it only one plate, but stainless steel is much stronger, so we position it on the both sides of it. And due to the middle of the beam have to bear only a few states, so we use low weight as aluminum. Next is our calculation. So we decide to transform all of them into stainless steel. We have to find centroid.
It is 2.6 mm from the reference.
We can calculate maximum bending moment, that the tension type is the maximum bending moment. Finally, we can find the maximum force is equal to 640.8 Newton.
In the second beam, we try to develop our beam. First, when material is deformation, it will be difficult to deform, so we bend the material to C-shape because it can bear the vertical force, and we choose to bend stainless because stainless has stronger than other material. Second, stainless can bear the compression and tension force, so we arrange it on the top and the bottom in our beam.
The calculation of second beam. This is the cross-section of the beam. We transform it to steel. After that, we calculate the centroid of the cross-section, that is 2.17 and 4 mm from the bottom, and then we can calculate the moment of inertia. Next, from the formula we can find the maximum bending moment. So the maximum bending moment that the beam can bear is 12.69 Newton meter, and the maximum load is 507.6 Newton.
This graph shows that the maximum load which our beam can bear is equal to 785.53 Newton, and that is much more than the value which we calculated. Our first beam specific strength is equal to 11.06.
From the result of our test, the beam can bear the mass force, but the beam is mass weight too. That is important factor with effect to efficiency. In the first time, we didn't think about clearance of beam thickness because between the metal plates has a gap.
The result of the second beam. This graph shows that the maximum load which the second beam can bear is 280.5 Newton. It can bear lower than the calculation in the first. Then we can calculate for the specific strength by this formula. Unfortunately, the second beam have the specific strength is just 4.75. The efficiency is very low. That is because the thickness is just 4 mm and the beam have complicated to build, so it happened the mistake from the design.
Suggestion as development. We have two ideas about it. First, the design. Since the design is directly affect to build the beam, if the process is difficult and complicated, such as cutting and pull down, they will affect to inconnection of metal plates and have a gap between the plates. So we have to design the beam in a simple, but it has good efficiency, like our first beam. Okay. Second, the process of building. The process of building is the most important part, especially cutting the metal plates. We can see in our second beam that is complicated design because we have to make a curve on it. It makes the mistake cutting and has a blank space inside, which is the weak point of our beam. It's in case of pull downs, we have to make it smooth, constantly surface.